And we are going to be starting patterns today, and patterns is a super fun topic. So I'm hoping that we can have a little bit of fun with it. There's a lot of terminology with patterns. So we're going to kind of go through some words today to make sure we're all on the same page as each other. And then we get to kind of get into some examples a little bit later. Okay, so in grade 11, you deal with two types of patterns. So in grade 11, we have two different types of patterns. Does anyone know what those two types of patterns are that we deal with? And if you don't, it's okay. But I'm here for suggestions. Oh, geometric is actually one that we're only going to do in matric. So in matric, we do a geometric sequence. So in grade 11, we do an arithmetic one, arithmetic sequence, which is just a fancy word for a linear sequence. And we have a quadratic sequence. Those are the two that we deal with in grade 11. So arithmetic or linear, so linear and quadratic. And then in matric, we bring in a geometric sequence. So a geometric sequence could look like this, like if you have 2, 4, 8, 16. So it's working on the number before. Okay, so we are only going to worry about linear and quadratic over the next couple of weeks. Those are the two we are going to focus on. So I'm now using this word sequence a few times. What is a sequence? In like non-fancy words, what's a sequence? Yeah, it's a pattern. A continuous pattern, a pattern or a group of numbers. So an example of a sequence is if I had like 1, 4, 7, 10, that is an example of a sequence. So sort of a group of patterns or numbers. So the way we can see that this is a continuous pattern because each time I am adding 3. So I'm doing the same thing every time to get to my next number. Okay, what is a term? So what would be a term when looking at something like this? So if this is my sequence, what would be a term? Yeah, it's good. It's a value in that sequence. So if I have a look at the sequence I have over here, that would be term 1, that would be term 2, that would be term 3, that would be term 4. So a term is a number in the pattern. Or sequence. Okay. What does the notation T1 mean? So if we saw T1, what does that mean? Exactly. All that means is T1 just means term 1. So if I had something written like this, if I had term 3 is equal to 7, what that's saying is term 3 or the third term is equal to 7. So that's all that that's meaning. And that is this term over here, term 3. So the third term in my sequence. Good. Okay. Are we happy so far? Yes. Great. Okay. Oh, I'm giving you all the answers. Get off that screen, answers. Thank you. Okay, so if that is term 1, then term T2 would be term 2. So it would be the second term in the sequence. And those are sort of our big numbers. Okay, if we have a look, let's have a look. Sorry, I just see Leander. Yeah, they always tell you the position of the terms in the sequence, exactly. They're going to tell you exactly where it is. T1 means first term of the sequence. Yeah. Okay. Given the sequence 3, 6, 9, 12. Okay, so if we have a look at this, then this would be term 1, this would be term 2, term 3, term 4. If we looked between them, each time I'm adding 3. So I'm adding the same amount each time. So what I have is a constant difference, because I'm adding the same amount each time. So in this case, our difference would be 3, because we're adding 3 each time. If we looked at this and we wanted to write these in sort of separate bits, like if I broke that up, I could write that as T3 is 9 or T4 is 12. So all this is different notation of writing that. And it's quite useful to us because it shows us sort of what's going on in the sequence, and often it's going to help us with our simultaneous equations as we move through. Have you got it opened again? No, I keep on showing you the answers. I hope I'm quick enough so that you can't see them. Okay, so if we know that T1, T2, T3, all of those are term 1, term 2, term 3, what would Tn mean? What would that mean? Because now I don't have a number, so I don't have a position. So what could that mean? Yes, good. Tn is the nth number. So it is what we call the general rule. And in this case, it's the formula for the pattern. So whenever you asked for Tn, they're asking you for the rule of the pattern. They're asking you for the general rule. Exactly. It's an unknown term, but n is going to be our end number of terms. Okay. I'm just going to zoom out quickly. If you wanted to take a screenshot, you can. Then we'll go to our next one. Okay. So let's have a look at this first example. Whoop, bit too much. If the general term of a linear pattern, sorry, missing an n there, is Tn equals negative 2n plus 1. So this is my general rule. This is my pattern. Okay, write down the first 5 terms of the sequence. So if I want to work out my first term, so for term 1, that is when n is 1. So we're going to say negative 2 times 1 plus 1, which will give us negative 1. So now I know that term 1 is negative 1. We can do the same for term 2. There n would be 2. So negative 2 times 2 plus 1. So that'll be negative 4 plus 1, which will be negative 3. If I did this for term 3, it would be negative 2 times 3 plus 1, so negative 6 plus 1, which is going to give me negative 5. Term 4, negative 2 times 4 plus 1, give me negative 7. And then term 5, negative 2 times 5 plus 1 is going to give me negative 9. So if I had to write the first 5 terms of the sequence, it would be negative 1, negative 3, negative 5, negative 7, negative 9. Seeing a lot of positive numbers there, Uyanda. Okay, so what do you notice about the sequence? What do you notice about this? No, don't look. What do you notice about that? Yeah, good. Negative 2. So every time I'm subtracting 2, each time I'm subtracting 2. So what I have is a constant difference. So my difference, or D, is negative 2. And whenever you have a linear or an arithmetic pattern, you're going to have a constant difference. And we always call that difference a little small d. Okay. All right. I would like you to give this a try. Yep, always. We always call the little d the difference. I'm going to give you a couple minutes to give this a try, and then I will talk you through it so that it's not scary. So start with just this first part for A. So think about what my next few terms would be. So this is term 1, this is term 2, this is term 3, this is term 4. So what would term 5 be? What would term 6 be? And what would term 7 be? Sort of a good way to start. Yes, I like that, Uyanda. Absolutely. You see here you had 1D, and then you had 2D, and then you had 3D. So my next one would be A plus 4D. Then I would have A plus 5D. Then I would have A plus 6D. So close. I'm seeing some really good suggestions. I'm giving you a little bit of extra time to give it a try, but I'm seeing some very good suggestions. Let me just, okay. Okay, let's have a chat through this. So this is term 1, this is term 2, this is term 3, right? What am I increasing with each time? What is my constant difference? What am I adding each time? Good. I'm adding a D each time. Okay, cool. So my first term, I've just got an A, right? And then my second term, I've got A plus D. So in term 2, I have 1D. In term 3, I have 2D. In term 4, I have 3D. So my number of Ds is always one less than my term number, if that helps, right? So if we think of our general rule as a TN, don't worry, because they always give this to you. I just wanted you to see where it actually came from. If we have our starting term, which is A, and then we're adding on our term number. So remember, term 4 had 3 Ds. So our term number minus 1 times D. So let's see if that works. So let's have a look for term 6. So that would mean that N would equal 6. So Tn or T6 would be A plus 6 minus 1 times D, which would be A plus 5D. Ta-da! So this is our general rule. And this is always going to be given to you. And it is going to be your arithmetic or your linear formula. Now, what I would like you all to do when you see this formula is I would like you to put this D in brackets, because something I see all the time is that if the D is, say, -2 or -5, it lands up getting subtracted instead of multiplied in. So you will have this formula on your formula sheet. I highly encourage you to make sure that D is in brackets so that you do not fall prey to any mistakes. Okay. Take a screenshot if you would like, and then we're going to try and see if we can put this to use, if we can get an example from it. We're going to talk about that now. Don't you panic. Okay. So let's start with this. So we've got a sequence. We've got 3, 7, 11, 15. So this, let me just get a different color happening here. This would be term 1. This would be term 2. This would be term 3. This would be term 4. Okay. What am I adding each time to get to my next term? 4. Okay, so my next 3 terms, what would term 5 be? What would term 6 be? And what would term 7 be? Good. We're just going to add another 4. So 19, 23, 27. So each time we're just adding 4. Okay. So now we're going to think about our formula because now we have to figure out the general term. So our formula looks like this. Okay. There's some important things here. The A is the first term in your sequence, so T1, and D is your constant difference. So in our situation, what is A? What is the value of A? Three. Good. Our first term was 3. So that's A. What is D? 4. Good, because that is our constant difference. So then we just put that into our formula. So we say Tn is equal to 3, because that's my A, plus n minus 1 times 4. So Tn is equal to 3, 4n minus 4. So now I've got 3 minus 4. So my n answer is going to be 4n minus 1. And then it's not so scary. Take a screenshot, and I'm going to give you one to try. No, it's not so bad. I'm just going to quickly turn the lights on, guys. I won't be long. Give me a second. Of course it works. Why wouldn't it work? Why would I give you something that doesn't work? Okay. So you are going to do this one now. Just making sure. I will write the formula for you here again until you are feeling more comfortable with it. I would like you to give this one a try and find your general rule, your general term for this one. Yanda, I am not hating that answer. Abu, I'm not hating that answer. Do you see now why it's useful to have the D in brackets? Yeah. Okay, I'm going to give you a little bit more time for those who are still working, and then we'll go through this one together. Okay. So when we're doing this, we care about two very important things. We care about our first term and we care about our constant difference. So in this case, our first term is -1 and our constant difference is -2 because I'm subtracting 2 each time. Okay, so Tn is equal to my first term, -1, plus n minus 1. And then on the formula sheet, it just says D. So then we would have -2. And that is why I cannot stress enough how important these brackets are. Because if you -2 and you don't multiply it in, you are going to get completely the wrong answer. So keep it in a bracket. And we're going to multiply that -2 into those two terms. So we have Tn is equal to -1 minus 2n plus 2. So Tn is equal to -2n plus 1, or 1 minus 2n. And that would be our general term for that one. Now, I know you guys hate fractions, so fraction question next. That you're doing the same thing. You're trying to find the general term. Why? Because you hate them. I have to give you things that you hate. Out of love. I'm giving you things that you hate out of love for you. I'm not saying a word, Oyanda. I'm going to let you suffer. So don't panic when it comes to fractions and Nelly. So Nelly, sorry, I'm full blocked up at the moment. Just use your calculator. So take this term and subtract that term, and take this term and subtract that term. And then you'll be able to get your difference quite nice and easily. And once you have your A and you have your D, you just pop it into the formula, and I'll show you how to work it out so that it's not so scary. There's something there I don't like. No, it's because there's a sign that's incorrect. Okay, so let's have a look at this. Our first term is 0, right? So A is 0. D, to go from 0 to 3 comma 2, I'm adding 3 over 2. I'm adding 3 over 2 each time. If you want to make your life a little bit easier, you can make them all with a common denominator. So we have 0, and then we have 3 over 2. And then if I needed 3 to be something over 2, it would be 6 over 2. And then I have 9 over 2. And then it's quite easy to see that I'm adding 3 over 2 each time. So sometimes it's easier to write your fractions with the same denominator if you're wanting to visually see it. Okay, so now we know that our D is 3 over 2. Okay, so then let's pop that into our formula. So Tn is equal to 0 plus n minus 1 times 3 over 2. We're going to take that 3 over 2, we're going to multiply it into those two terms. So Tn is equal to 0, so 0, 0, we can leave it out. 3 over 2, n minus 3 over 2. And that's our final answer. That's our general term, or our general rule. Feel free to take screenshots. We're going to try something slightly different in our next question. Lots of O's. I'll take those O's. Those O's feel positive. There's got to be some kind of biology joke there with blood types and O positive. Your multiplication was wrong. Okay. So this question says, determine which term of the sequence, -4, 1, 6, is equal to 56. So we're going to chat about this a little bit first, and then I'm going to give you some helping hands, and then I'm going to let you work some of this out. So we need to figure out which term. So that's the n value, right? This Tn is equal to 56. We need to figure out what that n is. Okay. So let's look at the information we have. Firstly, what is my A? What is my first term? Good. -4. Term 1, term 2, term 3. Okay. D is the difference between them. How am I getting from one term to the next? I'm adding 5. Okay, so my D is 5. We know that Tn is 56, and we don't know what n is equal to. So your first mission is to figure out your formula. So I want you to figure out this dude. That's your first mission. Right? So let's put in our information. So Tn is equal to -4 plus n minus 1 times 5. So we're going to multiply that 5 in. So Tn is equal to -4 plus 5n minus 5. So therefore Tn is equal to 5n minus 9. Okay. Now they've told us that we're trying to figure out what n is when Tn is 56. So they're telling us that this is 56. What is that? So if this is 56, solve for n. So I'm going to move my 9 over. So I'm going to have 65 is equal to 5n. Therefore, n equals 13. So T13 is equal to 56. If you have questions or if things don't make sense, please ask me. I'm happy to help. Just pop them in the chat and I will help away. This would probably be at least 3 marks. I mean, I even highlighted it. I underlined it. Yeah, it's not so bad. Okay. Let's try one where we're going to do some simultaneous vibes here. So I'm going to let you kind of work this one by yourself. I'm going to give you a little bit of a helping hand because we haven't done a question like this. And then I'm going to let you give it a try. They've given us some information. I'm just going to rewrite our formula up here until you know it a little bit better. They've told us that T4 is equal to 13. And they've told us that T12 is equal to 37. Okay. I'm going to do those actually in 2 different colors. So if I had to put this into the formula, T4 is 13. So that means that my Tn is 13 and my n value is 4. Okay, so if I had to put that into the formula, that's what that would look like. So I have the A unknown and I have the D unknown. And if I had to put this into that formula, my output, or my Tn, is 37. And then I'm going to have A plus 12 minus 1 times D. So I want you to simplify those 2 equations. And then I'd like you to do a simultaneous equation so that you can find the values of A and the values of D. And then you'll be able to find your general formula. Because once you have A and you have D, you can find your general term. I'm just going to start simplifying the equations, but I'm not going to do the rest of it just so that you can, if you're feeling panicky, at least you can get an idea of what's going on. Okay, I've put some helping hands on the board. Oh, I'm very curious to see what follows that. So you got I like that D is equal to 3. What does A equal? And A is equal to 4. I like that too. So what's your general term? What's your Tn? Yeah, I'm liking that. Okay. So we're going to do a simultaneous equation with these two. So basically what I'm doing is this is equal to A, and this is equal to A. And since A is equal to A, I can make those two equal to each other. So I can say 13 minus 3D is equal to 37 minus 11D. So 8D is equal to 24, which means D is equal to 3. And once we have 1, we can sub it back into either of these. So therefore, A is equal to 13 minus 3D, but D is equal to 3. So therefore, A is equal to 13 minus 3 times 3. 13 minus 9, which means A is 4. So now we know what A is and we know what D is. Then we can pop it into our general term rule formula situation. So Tn is equal to 4 plus n minus 1 times 3. Multiply that 3 in. 4 plus 3n minus 3. Therefore, Tn is equal to 3n plus 1. And this would be at least 5 marks. How are you feeling? Yay, meh, or nay? How are we feeling with patterns so far? Are we feeling okay? Good. Okay. Take a screenshot if you would like. Yeah, it's okay. I'll take that. Okay, very similar to what you've just done. So they've given you these two statements. So you're able to do your simultaneous equation because they've given you that statement and they've given you that statement. And they're wanting you to work out T20. So if we work out our general term or our general formula, you can just put your n is equal to 20 there and work out what that is. So it's very similar to what you've just done. So it'll be good practice, kind of reinforce what we've just done now. Give it your best go. It'll be worth at least 6 marks for this one. So I'm going to give you some time to figure it out, and then we can go through it step by step. Okay, 3 more minutes. Yo. So I like everything that you've written, Abu, except I wouldn't write it as Tn equals negative 93. I would write that as T20 equals negative 93, because that's not Tn, it's term 20. Okay. Yeah. Okay. So let's go through this step by step. So my light blue one, I have 20 negative 28 equals A plus 6D. So I'm just going to isolate A. So A is negative 28 minus 6D. And in my dark blue one, I have negative 68 equals A plus 14D. So I'm going to isolate A again. So A would be equal to negative 68 minus 14D. So now I can see that this is equal to A and this is equal to A. So we can make it a simultaneous equation. So we can say, therefore, negative 28 minus 6D is equal to negative 68 minus 14D. So 8D is equal to negative 40. Therefore, D is equal to negative 5. Step 1. Can submit it into either one of these. I'm going to submit it into my first one. So A is equal to negative 28 minus 6 times negative 5. So A is equal to negative 28 plus 30. Therefore, A is equal to 2. So now I have D and I have A. And if I have D and I have A, I can find my general term. So Tn is equal to 2 plus n minus 1 times negative 5. Multiply that dude in. Negative 5. Ooh, my sign. Negative 5n plus 5. So Tn is equal to negative 5n plus 7. Now they've asked us for term 20. So now they're saying n is equal to 20. So T20 is equal to negative 5 times 20 plus 7, which means T20 is equal to negative 93. Not so bad. We just have to combine a lot of knowledge that we have in maths of algebra and simultaneous equations and kind of put it all together into one. But it's a lot of marks for something which isn't too bad if we understand the terminology and we understand how to make our original equations. Like if we can make these equations here, we're golden. Shall we do one more question for the night? Take a screenshot if you would like. It's a lot of maths. Which one do I want you to do? I don't want you to do this. Let's just use. No, I actually don't want you to do those questions because I want us to talk those through. I don't want you to have to rush them. So how about to finish this off, I'll give you a sequence and I want you to determine the rule for me. I would like you to determine the general terms for C and D. More TN practice, yes, because I don't want to give you the ones where you have to do at the end yet, because we need a little bit more time than we have. So just 2 TN questions to end us off, because we don't have enough time. And I don't want to rush those concepts. So remember, you need A and you need D, and then you can always work out your general term. Nice. So for C, A is -8, D would be 6. So Tn equals -8 plus n minus 1 times 6. Multiply that 6 in. Tn equals -8 plus 6n minus 6. Tn equals 6n minus 14. So there's C. And D, my difference is increasing by a quarter each time, because if I change that, it would be 2/4. So I'm adding a quarter each time. So A would be -1/4 and D would be +1/4. So Tn is going to equal -1/4 plus n minus 1 times 1/4. We're going to multiply that in. So now what we have is we have -1/4. So let's keep this over here. We've got a quarter in, and then we have a -1/4 minus another 1/4. So that's -2/4, or you could say -1/2. And that, my lovely 11s, brings us to the end of our first lesson on patterns.